Hello and welcome to this fourth lesson in the series, An Introduction to Stata. Today we're going to be looking at manipulating strings and dates. There's quite a lot to cover, quite a lot of code, but I hope that the previous three lessons have made you all at least familiar with how Stata works, how we put in commands, and how we go about doing things in Stata. So specifically, this lesson covers how to convert strings to both numeric and labelled numeric variables, and vice versa. Introduces some useful commands in manipulating strings, and talking a little bit about the egen command, how to format variables, and then how to manipulate dates. So first off, let's load in the dataset. So either lesson 03 with your initials or lesson 4, either's fine. There we are. Quick look. Problem with multiple screens, I have to look over there sometimes. Okay, so we have a variety of variables, including several string variables, they're the red ones, and several, and another one, a couple of dates. So a date that currently is a string, we'll be fixing that, and dates that are Stata date code, and some labeled numeric variables too, and the regular numeric variables. Good. Okay, so section 4.1, converting string variables to numeric variables and vice versa. So distinct from labeled numeric variables, this is converting strings, of which we have calories being the only example, that were imported as strings into Stata, but they're numbers. They should be treated like any other numeric variable. The reason that variables can be imported as strings rather than numbers is because sometimes, there we go, they have non-numeric characters in them. So NR comes up a lot because various programs use NR to represent missing, so not recorded. And this carries through into getting exported and then imported into Stata. And because it has these non-numeric characters in, Stata won't delete them, it will just code it as a string. So we need to deal with that, and we can. So there's a couple of things we can do. There's a command called dstring, and there is a function called real. So a command is what we've been using so far. So the dstring command is a command like the others we've been using. The syntax is dstring, and then we give it a string variable, and then we generate and then some new variable name. With the regular, we have to call it a unique name, and it can't start with a number or and can't have any characters in. Either generates, or we could repulse, or we could replace the variable. So we can generate a new variable, or we can replace an existing string variable with a numeric version. In general, we like to create new variables because we can check them, we're not overriding data, and it's kind of a little bit safer. But replace works fine if you know the command works. Okay. So that's the command. The function is the real function. And in the course book, I've separated out commands which don't have these brackets after them, and functions which do. So a function is an expression. So it doesn't work by itself. The dstring command, we can put it in and it runs on a single line and it works to do something. A function needs a command to go with it. So often we'll either be generating new variables using these functions, or we'll be replacing variables using these functions. And the way this particular function works is we can say we want to replace an existing variable equal to, and then real an existing variable. And what real does is it converts strings into numbers. So it would convert 1605 the string into 1605 the number, and so on and so forth all the way down. The dstring command is actually a wrapper for the real function. So all a wrapper is a command which takes the function and puts additional code around it to make it more usable. dstring takes the real command and puts code around it to make sure that you don't accidentally overwrite data that you actually want. So we'll go through examples of both. And we'll go through lots of examples of other functions in Stata too. Okay, so calories is the example we have, and we want to dstring it, i.e. turn it from a string into a number so we can use it as if it were a number, not a string. If we try to do it with nothing else but the basic syntax, so there we go. Dstring our existing variable calories, generate our new variable calories underscore numeric, press enter, and this doesn't come up in red because Stata actually hasn't done anything this time. The message calories contains non-numeric characters, no generate. It's refusing to generate this new variable because there are the non-numeric characters, the instances of nr in calories, that means Stata will not, or rather the dstring command will not convert this. So you can see no extra variables been generated. We can get around this in a couple of ways. The first way is we can add an option, force. So like always, Stata is trying to prevent us from overwriting data or losing data in any capacity. In this case, it wants us to specify the word force as an option, as an explicit acknowledgement that we're aware there are non-numeric characters, we still want to do it. And if we use the force option, it does it. And it tells us, again, calories contains non-numeric characters, but it's still generated a new variable. Calories underscore numeric generated as int. Int is the precision of the variable that was just generated. So numeric variables all have a precision attached to them. Ones that are just integers are usually int, so whole numbers have the precision of int. Variables that have decimal places are usually floats or doubles. Now, there's a bit in the course book about kind of the more technical explanation about the different precisions, and there's an example of how it can go a bit wrong. But because almost all of the time there is no issues with this, Stata will generate variables. It will generate variables at the precision it needs to in order to have as much information as possible, and it'll do everything fine. So it's only very rarely that it would ever cause any problems, and feel free to read the technical note in the course book if you are interested, but I won't say any more here. Okay, back to the dstringed version of calories. There we go. So it's generated a numeric variable from the string variable. It's also ordered it for us, which is kind of nice of it, to be just after the variable it dstringed. And if we scroll down, the nrs as non-numeric characters have become missing. This would happen whatever the non-numeric character was. If Stata can't convert it into a number, it's going to get rid of it. And it does tell us 13 missing values are generated, so that would be the total number of observations that are nr in the calories variable. We can just check that. Count, so this is our command for counting things. Count if calories is equal to nr in quotation marks 13. So those are the 13 values that are now missing in the calories numeric variable. So I said there was a couple of ways to deal with turning calories into a numeric variable. The second way is that if we know there's only one instance of a non-numeric character or non-numeric string in the variable, we can just get rid of them, set them to missing, and then we can use dstring without the force command. So let's do that quickly. We want to replace calories equal to missing, no, blank string, sorry. Replace calories is equal to missing if calories is equal to nr, 13 real changes made, good, that's how many I would have expected. And then the first command I tried dstring calories generate calories underscore numeric. This won't work because we actually have calories underscore numeric already in the data set. So if we tried it, generate contains existing variables and or illegal variable names. I haven't seen Stata come up with illegal variable names before. That's good. But it exists, so we can't overwrite it. Stata doesn't like overwriting variables that exist. So I'm going to stick a 2 in there, and that works fine. It appears, there we go, it actually appears directly after the variable it is destringing, so it has taken over the place next to calories instead of calories numeric. Okay, so instead of using the dstring function, we can use the real dstring command, we can use the real function. To do this, function always go within other commands, so usually generate or replace. We're going to generate calories numeric 3, so the third version of this particular variable, equal to, let's put an underscore in as well, equal to real calories. There we go. So generate new variable name is equal to, and then our function. So real in this case means convert to a real number, and we want it to convert the real number, the string values from the calories variable. And it works. It doesn't give us this extra line of output. So this is partially what the dstring command adds to the real function. It tells us various things. I think real would work regardless of whether we had non-numeric characters in the variable as well. So there's kind of less protection against things going wrong using the function rather than the command. You can use either, it really doesn't matter. But it's also worth pointing out that dstring orders the variable for us, generate doesn't without an extra option, so it's stuck calories numeric 3 at the end. We can just do a quick check. So if we want to know whether what we just produced is the same, whether the real function does the same thing as the dstring command, we can count if calories underscore numeric is equal to calories underscore numeric underscore 3. And it's counted up 1,000 observations that are identical between the two numeric variables we just created using the two different methods. So they're doing the same thing, and we can be happy about that. Okay, that's converting string numbers, so string variables that contain just numbers, into a numeric variable. Sometimes we want to do the reverse, converting numeric variables into string variables. So this is usually a simpler task because we're not worried about the precision when creating string variables. All the information will be copied across to the string, and Stata will use as many characters as necessary in the string variable to make sure no information is lost. So, like there are two ways to dstring a variable, there's two ways to string a variable. The first is the toString command. So this is the inverse of the dstring command. It converts numeric variables to strings. And we can also use the string function. We'll do both. So we want to convert calories numeric back into a string variable. There we go. So toString works the same way dstring works in its syntax. ToString, existing variable, numeric variable, comma, and then the option generate our new variable name, calories string. It gives us a little bit of output, calories underscore string generated as str4. So this is telling us it's a string variable and there's 4 characters shown on screen. If we look at it, there it is. So it's generated next to the calories numeric variable. There's only ever 4 digits available, so it's made the string variable as narrow as possible, which contains only 4 characters. If we were to replace one of these with a much longer string, Stata would just automatically increase the number of characters available. So we don't need to worry about it. It's just that's what string 4 means. Okay, that's using the toString command. We can also use the _2. We can also use the string function. String, and then the variable we want to turn into a string, calories numeric. And I'm going to include another option here. So calories string 1. To make it easier, generate allows you to place new variables before and after existing variables. In this case, I'm just going to place the newly generated calories underscore string underscore 2 variable after the calories string variable. And let's look. Okay, so this is the original calorie string variable generated using the toString command, and this is calories underscore string underscore 2 generated using the string function, and they are identical. We can prove it, give or take, using a count command again. So count if calories underscore string is equal to calories underscore string underscore 2. And it's 1,000 identical values. Good. So we can also check whether the variables that we've converted into a numeric variable and then back into a string variable are identical to the original calories variable. And that's easy enough to do. Just delete the word string there. So count if the original calories variable is identical to the variable that we've converted to a number and then back from a number into a string, and it's 987 rather than 1,000 truly identical cases. This is because, let's scroll across and down. There we go. In a true string, missing values are coded as a blank space. When we convert numeric variables into a string, the full stops, the missing numeric values, get converted to a literal full stop. So the 13 blanks have been converted into full stops. We can fix that later if we want to, but it's not really a problem right now. Okay, we have more instances of manipulating strings in a little bit. We could just use a simple replace here. Replace calories string is equal to a blank string, so 2 quotation marks next to each other, if calorie string is equal to a full stop. But there's really no need. So after doing all that and creating those variables, we're now going to drop everything that isn't the one we actually want, which is calories underscore numeric, because that's the most useful form of this variable, because we can do any number of things to it because it's now a number. So we want to drop calories, that's the original variable. We want to drop calories underscore numeric underscore asterisk. So this is everything that starts. There's supposed to be an underscore there, but I didn't put one in. There we go, calories underscore numeric asterisk. No, I'm just going to do that. Calories underscore numeric 2, calories underscore string, and we do want all of those to go. So everything that starts calorie string we want to go. And also we want calories numeric 3 to go as well. And I'm going to do something I didn't think I've done in these lessons before, which is these variables over here, you can double click to add them to the command window. So double click and it appears. But we don't want any of those anymore. So we've dropped them and we've kept the calories numeric variable because that's useful. Good. Okay, in the course book there's then the technical note that goes on for a couple of pages. Definitely not necessary reading, so yeah, feel free to skip. But let's go on to 4.2, converting string variables to labelled numeric variables and vice versa. So this is for cases where we have a string, and usually it is actually a string, not a number, and we want to convert it into a labelled numeric variable. So we want to convert it to numbers and have those numbers mean something. So this is usually used for categorical variables, so different groups, different levels of a variable. And often we do it because string variables are not useful for statistical commands, and likely other commands in Stata as well. Commands where we need a number rather than a string to get a meaningful output. So if we want to know whether hair colour affects your BMI, then we would use a regression command, but we can't use regression with strings. We need it to be numbers, even if we're looking at levels of those numbers. So we're looking at is having red hair different than having black hair in terms of BMI. We're still looking at the levels, but we need it to be numbers for Stata to understand what we're doing. So, need to run out. Okay, so yeah, you need to make string variables, even if they're categorical, into numbers before we can start doing stuff with them. We could do this using if statements, which is what we did in exercise 3.11, where we took sex and we converted it into a numeric variable and applied the label manually. In the answers, I said that there was a command we could use that would do that for us, so we'll go through that now. The command is called encode, and the syntax is we say encode, we give it a string variable, and we generate. There's no replace here. This isn't like toString and dstring. We actually need to generate a new variable with this command. So we generate some new variable or other. There you go, same rules apply with generate as ever. So let's encode sex. Encode, name of the variable that we're encoding, sex. And we're generating the variable sex underscore numeric. No output, probably means it worked. No massive errors anyway. And I'm just going to order it as well. So it's order sex underscore numeric after sex. We can't use the trick of using after in the encode command. It doesn't support that particular option. So we need to do it manually. There we go. So we have our variable sex, and we have the encoded version of that, where the females we can see are coded as 1s, the males are coded as 2s. So what encode has done is it's found out all of the unique values of the variable that we give it. So in this case, we just have male and female, both capital letters because we changed that earlier. It's put them out in alphabetical order, and it's created a label based on all those unique strings. So female and male. It's then converted all of the string values into numbers. So this is like creating a new variable saying if the value of sex is capital F female, we want the value to be 1 in the new variable we create, and if it's uppercase male, we want the value to be 2. And it's then applied the label it made to the new variable. So it's all the manual steps we did in the exercise 3.11 as a single command. And if we do label list, we can see the new variable that's being new label that's being created. By default, encode creates a label of the same name as the variable that you're creating. You can give it an option, so you can give it an option label brackets some other label name, and encode will create a new label of that name. If that label already exists, encode will try to use those labels, that label, to create a new variable using those number and string pairs of that label. sorry, it's easier to go through it than it is to describe it. Okay, so encode will do any number of categorical variables, so as many unique strings as you have, it will create a label containing as many numbers as that. It starts at 1 and it always works alphabetically. So first one's female, second one's male, because that is how it works alphabetically. That's not necessarily what we want though. So in cases where we have binary variables, it is usually preferred practice to have 0s and 1s rather than 1s and 2s, because Stata interprets 0s as being a bit special. So in some commands, logistic regression for instance, 0s are distinct from every other number. Every other number is categorized as has the outcome, and 0s are categorized as not having the outcome. In this case, we wouldn't get a meaningful result out if we tried using logistic regression, because both 1 and 2 are regarded as having the outcome. So we're going to redo the encode, and we will create our own label, and then make encode use our new label to encode sex. The first thing we do is we drop sex numeric, because we're going to recreate it. We also need to drop the label encode made for us, and we also need to write that the right way around. Label drop sex numeric, and then we're going to define our own label. Label define sex. We want the 0s to be female and 1s to be male. The important part of doing this, where we're creating our own label and then making encode use that label to encode a string variable, is that what we write here in the labels really matters. These have to be identical to what is in the string variable, because otherwise Stata won't be able to find and code up these strings correctly. So capitalization matters. These have to be uppercase. If we put in lowercase, it wouldn't find any lowercase f females, so it would think they don't exist, and it would stick on uppercase f female at the end. Okay, so label define sex, 0 female, 1 male. We're then going to encode sex again, same as we did before. Create the same new variable, but with the added option of label sex. So encode, but please use this label we've just defined rather than creating one yourself. We're going to order sex numeric after sex again. Take a quick look. There we go. So all the females are female, all the males are male. Good. That's what we wanted from this command. But this time, the females are coded as 0s and the males are coded as 1s. So now we can use this in various commands where 0s and 1s are meaningfully different, but every other number is the same as it being a 1. Good. We also want to label the variable because we are diligent about making sure our variable labels make sense. So encode creates a variable label but gives it the same variable label as the string variable it just encoded. In this case, we want it to say sex, numeric. Go. Good. Okay. As well as looking at the spreadsheet view, we could tabulate sex numeric. When we're making sure that the variables we just created are in fact identical to the variables that we just created them from, we usually want to put in the missing options to make sure that missing values were coded for correctly. In this case, the blank values of sex, so the missing ones, have been coded as missing values. That's exactly what we want. Females are female, males are males. Happy. Also want to just check. Let's put the no label option in. And we can see females are 0, males are 1s. Good. Right. That's good. We have the numeric labeled versions of sex. Let's do the same for hair color and income. hair color, we're not actually worried about which order the hair colors go in. Alphabetical makes sense, and it doesn't matter that they start at 1 and go up. That's fine. So encode hair color, gen hair color numeric. Good, no output, so that probably worked. Order hair color numeric, and I want that to be ordered after hair color. Very good. Hair color numeric. Let's take a quick look just in case. Yeah, this all looks fine. And then we can label the variable again. And you see I'm tapping through again because I'm going to start spelling things wrong at some point. Hair color. In fairness, that was completely unnecessary because it took the label from the hair color variable. Oh well. For income, we're actually going to define this because income does have a prescribed order to it that might not be reflected when we look at it alphabetically. So less than 18,000 should come before 18 to 30,000, which should come before 30 to 50,000, which should come before 50,000 plus. If we were to do it alphabetically, the less than symbol actually comes after numbers for whatever reason, so alphabetically this would come last. We don't want that, so we're going to define the label income first and then make encode use that label. So 18, 1,000 to, we want to be 18,000 to 30,000. 3, we want to be 30,000 to 50,000, and 4, we want to be 50,000 plus. And I take a quick look to hope that I spelled that all correctly. Otherwise the encode will go wrong. We can always fix it if it does come to that though. So we've got our label. We're now going to encode income, generate income numeric, and use the label income. Okay. Also, we want to order it. We don't need to label it. Where is it? Income. Guess income in pounds makes sense to me. Let's take a quick look. Our values are 1 for 18,000. That should be 4. Good. 18,000 to 30,000 is 2, and 30,000 to 50,000 is 3. Good. Okay. We can also quickly do label list, just to make sure. So yes, the sex variable, sex label, sorry, we generated that, and the income one. The hair color numeric variable was generated by encode. 1 black, 2 blonde, 3 brown, 4 grey, 5 red. That's all fine. I'm happy with that. So that's encode. Now let's go the other way. Labeled numeric variables to string variables. There's various reasons we want to do this, usually around creating tables and things, but it's certainly a good thing to be able to know how to do. So encode takes us from strings to labeled numeric variables. Decode does the opposite, takes us from labeled numeric variables to strings. And the syntax is the same as for encode, just with the variable names kind of reversed. So let's do an example. Decode income numeric and generate income string. What we're looking for is the new variable income string to be absolutely identical to the original variable income, because we want to make sure that when we convert data from string to numeric and then back again, we don't lose any data. So let's do our normal count. Count if income string is equal to income. 1,000 cases of yes, yes it is. So we can be confident that when we used our encode and decode commands, we didn't lose any information. Right, so let's look at income again. In the exercise data set, I coded these so that they have a pound symbol in front of them, and I would actually prefer that. So the ways that we could go about changing that are to go into each of these, do if statements and change. So replace income is equal to less than £18,000, but with a pound sign after the less than, if income is equal to less than 18,000. That's 4 commands because there's 4 different levels, which is too much work. So what we can do is just change the label of the numeric variable. So all the underlying code for this income numeric variable is 1, 2, 3, 4. That doesn't change regardless of what we do, but we can apply a different label so that each of these has a pound sign in front of it. So going back to the last lesson, we're going to use a label define command, this time with a modify option. So let's change 1 to be less than £18,000. 2, we want to be £18,000 to £30,000. 3, we want to be £30,000 to £50,000. 4, we want to be £50,000 plus. And we want the option modify because Stata doesn't want us to overwrite data. Click it in, nothing appears. Let's take a look. There we go. So the numeric version is now labelled slightly better than the string version, and with relatively little effort. We had to write out all of these label values again, but that is less effort than writing out 4 lines of code to change each one of these separately. Okay, we've labelled the numeric variables for sex, hair colour and income, so we don't need the original or the recreated string variables. So let's drop them, tidy up the dataset, drop sex, hair colour, income and income string. So we're keeping the numeric versions of all of the variables. And finally, let's rename the numeric variables so they have so they don't have numeric in their name. So rename sex. Remember that if a variable is unique, then you don't need to type it out in full. So if you tab through and it just comes up with the entire name, it means it was unique when you started to press tab. So I don't need to actually say hair underscore color underscore numeric. I can say hair, and Stata will know what I mean. When you're typing out the new variable names, you do need everything because otherwise it will just create it as what you type in. But if we can save time, then we should. There we go. It's worth pointing out that this was quite a lot of effort. We did the same sort of thing 3 times. We encoded a variable 3 times. If we're doing commands that are repetitive like that, we can usually put them in a loop and have just 1 line of code that is the command line, and then a loop around it so that it does those commands for sex, and does those commands for hair, and it does those commands for income. And this is an absolutely hugely beneficial part of coding in Stata, which is using loops, and we'll cover that in a couple of lessons' time. Okay, for now, on to section 4.3, manipulating strings. So, string variables might need processing. This is just in general, but it might also be before we can turn them in, before we can encode them and turn them into something useful. So Stata has a variety of commands that can help manipulate string variables, and we'll go through quite a few in this section. These are just the commands that I find particularly helpful and have used in various projects I've done. It's not an exhaustive list, so there's plenty more commands that can help modify and manipulate strings. These are just the ones that I've found useful. So let's have a look. We actually have 2 string variables left that we need to do things with. Everything else has been coded up nicely and looks good. We can use it in any analysis that we care to do. these two variables, favorite colors and date of BP measurement, we still need to deal with, fix, make useful. So favorite colors, this is just a list of 3 of someone's favorite colors. They're unique, so you can't have the same color twice. Date of BP measurement is just coded as we would normally, in human terms, code a date. This is not how Stata codes dates, and that, not the next section, but the one after, 4.5, we'll go through how to convert this nice string date that we can read into this, which is a formatted version of the date that Stata can read. For now, we're going to deal with favorite colors. In this case, we want to convert those 3 favorite colors that are contained in one variable into 3 distinct variables, and then eventually we'll encode it so we get them into numbers. Okay, so we don't need to list it because we just had a look at it. Okay, we do actually need to have another look at it. In Stata and other programming languages, there are delimiters. So these are characters or terms that separate each element of a list. In this case, we've got a list of 3 colors, usually. Sometimes we have blank spaces to represent missing colors. But we should have 3 colors separated by a semicolon. So the semicolon is the delimiter that separates each element of this, or each color in this list. The command that we're going to use to separate those 3 colors into 3 separate variables is actually a command I learned about this morning. I've previously been doing this in a quite slow and inefficient way, so after 10 years I am still learning how to be more efficient at using Stata, so I don't know if that's encouraging or not. The command works as follows. We have, it's called split, and this works in the same way as text to columns does in Excel. So we have split, and then we give it our string variable, and then we generate, and here we give it a stub. So a stub in Stata, this comes up in a few commands, is just the start of a variable name. So the way split works is it takes this stub and it adds numbers after it, and it keeps going depending on how many delimiters you have. So if you have 100 delimiters separating out 101 elements in a list, it's going to create a new variable, the first one, which will be the stub 1, and then put the first element of the list in there. The second element of the list goes in stub 2, and then stub 3, stub 4, all the way up to stub 101. I don't think there's an upper limit on how many you can have, so it will create as many new variables as you need, up to however many variables you're actually allowed to have in your version of Stata, which could be an incredibly large number. So, generate, and then we put a stub in. Pass, and here is where Stata isn't terribly helpful. Pass is the same meaning as delim in the import and export commands we used in the first lesson. So this option tells Stata what is the delimiter that you want to use, or you can have more than one delimiter, so delimiters that you want to use to separate out the elements of your list. In this case, the delimiter is a semicolon because it separates out the different colors. We could also use commas, or you can use just blank space, or you could use actual spaces. So pass, delimiters, and then we have a few more options. No trim, which is by default, split takes away leading and trailing spaces. So these are spaces at the start and end of words that shouldn't be there. So by default it takes it away. No trim means it leaves the strings in. Dstring, so this is the same command as we used just earlier in the first section of this lesson, which is turning numbers, literal numbers that are coded currently as a string, into those literal numbers. It won't work if you have non-numeric characters, but when you have a string variable separated by commas or separated by semicolons or even separated by spaces, then it'll import it as a string because it's numbers with some non-numeric characters as well. And just adding this option in can turn the new variables into numeric variables. We can also set a limit. So you don't need to set a limit, but you can set a limit. And there is some number in here. So you might just want the first 2 or the first 50 or the first element of your lists, in which case you can tell Stata, I don't want the rest of it, I just want all of the variables, all of the elements up to the nth element. Okay, so that's a reasonably long command. Let's try and use it. So we're taking the favorite colors variable and separating it out into 3 separate variables. So it's split, and then our string variable, favorite colors. We want to generate a new variable starting with color underscore. So it would be named color underscore 1, color underscore 2, and color underscore 3. And pass, we're going to use the semicolon as a delimiter. Type enter, and it gives us this helpful output, variables created as string, color 1, 2, and 3. We can scroll down and see them here. Spreadsheet view, there we go. So blue, yellow, and red has turned into blue, yellow, and red. And it's the same all the way down. The blanks are where the original string was blank, and it creates a blank whenever there is a blank in the original element. So there's nothing between indigo and yellow, so there's nothing between indigo and yellow in the new variables. Okay, let's label these. Label variable color underscore 1, first favorite color, 2, we're going to call second favorite color, and 3, third favorite color. There we go. And also we're going to order them. Order color underscore asterisk, implying I want all variables starting with color underscore after favorite colors. There you go. So we've got our favorite colors, and then we have our favorite colors, but as separate variables. There we go. So not that much code to make it actually quite usable. Now, the way I was doing this, and it's still useful to know about it because it's a slightly different command, is using the egen function ends. So a little bit to unpack. Egen is an extension to the generate command. So egen stands for extension, gen is generate. And this applies additional functionality to the generate command. There's a whole suite of egen commands, functions, sorry. It's one command with several functions. There we go. Egen extensions to generate. So egen, new variable name, is equal to, and then you have lots of different functions. So you can see them all here, and there's a whole list of them. We'll go through some in these lessons. In this particular lesson, we're only going to be looking at 2 though, and that's ends, which gives the first word or head or last word, or the remainder or tail from a string variable. So this does the same sort of thing as what we just did with split, but in a more manual and probably more controlled fashion. Also going to be looking at concat, because concat's quite useful. This is the same as the concatenate function in Excel and has various uses. So we'll look at both of those, and we'll look at other egen functions in other courses. So in this case we're using ends, and the syntax is we're going to generate a new variable equal to, and then our function is ends, and it's an existing string variable, And there's options that go with this. So we need to tell it a delimiter. And again, Stata is inconsistent in how it defines the option that we use with delimiters. So we've now had delim, which I think makes the most sense because there's a delimiter. We have punct here, so punctuation. And we had pass in split. So they all mean the same thing. What is the delimiter that we're looking at here? And then we have the trim option, which is the opposite to the no trim option, which means please get rid of the spaces before and after words, before at the start and at the end of a string. And then we have head, or we have tail, or we have last. And each of those has a different meaning, and we'll go through each of them. But it's which ones you want to save, essentially. So let's delete that and look at this again. So we have a variable with different delimiters. If we select the head option, everything before the first delimiter will be put into a new variable. So blue, red, yellow, indigo. It's what is color 1 here because it's everything that's before the first semicolon. Tail selects everything after the first delimiter. So if you subtracted color 1 and the first delimiter from favorite colors, you'd be left with yellow colon red, indigo colon violet, blue semicolon, sorry, green, blank, and then yellow. So it's everything apart from the first element of the list. And last, the final option, selects everything after the final delimiter. So this is color 3 here. Red, violet, green, yellow, blue, etc. You can use those options to do the same thing that split does in a more manual way. But you can also do things like select the last element of a list, which you can only get with split by doing it and then deleting all of the variables that you don't need. You only needed the last one. So there are circumstances where egen ends is more useful than split. So let's go through some examples. If we want the first color, we use ends, and we want it to be the ends of favorite colors. We give it our delimiter in the punctuation option, and we're just going to say a semicolon. And we want the head, so we want the first element of the list, the first color, and we want to trim any spaces. 44 missing values generated. Take a look. First color, blue. Good. That is the same as color 1, which is what we wanted. If we wanted the last color, egen last color equals ends. Favorite colors, punctuation, semicolon, and we're using last as well as trim. So we want the final color, final element of the list. Take a look, and we've got red, violet, green, yellow, blue, blue, indigo. So same as color 3. Good. If that's all we wanted, this would be a good way of getting that information without having to create every element in the list as a new variable and then selecting only the one we wanted. Finally, and this is where things get a little tricky because this is now a 2-stage process. So if you need anything other than the first or last color, element of a list, you may well be better off using split, but still. Egen x, so temporary variable, and I usually name my temporary variables x because I know I can delete them afterwards. Punctuation, semicolon, tail, and trim. So tail is the last of the 3 different options that we can use, and tail, there we go, creates this variable. So it's everything after the first delimiter. So blue, yellow, red has become yellow and red. Red, indigo, violet is indigo and violet. Blue, yellow, blue, green is now just blue, green. And then we can egen the middle color, and we're still using ends, favorite colors, punctuation of a semicolon, and we want now, not that, there we go. Egen middle color equals the head of the new variable x. Let's just put it in and have a look. X now has the middle color as its first element because it's everything after the first delimiter, the first semicolon, and we've taken the first element of x, which is yellow. So quite a lot of effort, but we now have first color, last color, and middle color, same as we have colors 1, 2, and 3, and they're all identical. So good, and probably good to know, although yes, quite a bit more effort. Okay, let's drop all of the variables we just created. Let's drop first, drop middle, and drop final? No, last. Yeah, drop first, middle, and last color because we don't need them. We have colors 1, 2, and 3. We also don't want x anymore. There we go. Okay, moving on to the concat command. So we've separated out the elements of favorite colors. There they are. We may end up wanting to put them back together, or we may want to combine string variables into a new variable for a variety of purposes. And if we do that, we're going to use the concat command. So egen again, new variable, equal to, and then we have our function concat, and we give it our variable. So you can have multiple variables because you're combining them. You may usually want multiple variables. We then have punctuation with a delimiter again. This time, instead of a delimiter being something that is inherent in our data that we want to pull out, this is a delimiter we give to the command, and this is what separates each of the variables that we have in our concat function. We can also decode as an option. So if you want labeled the labeled values, then don't use decode. If you want the numbers, use decode, I think. Okay, so let's use egen to create favorite colors 2, and we'll say we want to concatenate color 1, color 2, and color 3. We could specify color underscore asterisk because this will mean colors 1, 2, and 3. I believe it does it in alphabetical order, but it might do it in the order in which the variables come up in the data set. So this might bear a little testing, but it also means that if you have 100 variables you want to add together, it would be much quicker to arrange it in this sort of concatenation with the asterisk than it would be to type them all out individually. Either way, I'm pretty certain it's going to be 1, 2, and 3 in this case, so I'm going to leave it as the asterisk. I'm going to give it a delimiter in the punctuation option. And that's it for what we need. And then count if favorite colors is equal to favorite colors 2. And it's 1,000. Good. So every instance of the variable we just concatenated together is identical to the original variable. So once again, we haven't lost information. We can regain it if we need to. Good. We can also manipulate strings directly. So if you want to generate favorite color again, just in case you haven't had enough of generating favorite color, favorite colors 3, we can say we want it to be equal to color 1 plus our delimiter plus color 2 plus a delimiter again, and then plus color 3. Oh, that's very much in capital letters. Color 3. The plus symbol, when we're using string variables, adding them together means sticking them end on end. In this case, we've also added in just things that we put in quotation marks. And Stata will, let's do this first, and then generate another one. You can put anything in quotation marks and it will add it onto the end. So something else that goes on the end. And when we look at the variables, there we go. So favorite colors 3 is the one we generated just by using, we want it to be color 1 plus a semicolon plus color 2 plus a semicolon plus color 3. The reason they still have spaces is because these variables still have spaces, because the trim function of split doesn't necessarily always work. So we'll be fixing that in just a little bit. And you can see in the final variable I generated, whatever you stick inside quotation marks gets put onto the end with a plus part of a generate command using a string variable. You can also do fun things like gen x equals, I'm just going to say this ... like that. You can times it. So any string that you care to put into something, if you multiply it when you're generating a new variable, it creates as many copies of that and sticks them end to end as you put in. So I did this space ... space, and it's done it 5 times because I times it by 5. There are limited applications of this particular application of Stata, but it's good to know. So the favorite colors, all of them now, are not terribly useful because we have colors 1, 2, and 3, and we can do things with those that are more useful than having an entire list altogether. So I'm going to drop every favorite variable as well as x, which I just created there.